Factorization method I want to look at is factorizing of quadratic trinomials. Now, different teachers like to do this in different ways, and you may have learnt many different ways when you were in high school. I'm going to do these in the way that I like to do them, but if you've got another method that you prefer that works for you, that's fine as well. A quadratic trinomial is an expression that has three terms in it. That's why we call it a trinomial. And the quadratic part of the name quadratic trinomial refers to the highest power. So quadratic means it's got a squared as its highest power. So anytime we see a quadratic trinomial, we need to use this method to factorize it. To factorize a quadratic trinomial, what we're basically going to do is change this into a grouping in pairs problem. And the way that we do that is we are going to split up this middle term into two other terms, and we're going to be clever about the way that we do that. So this is the process to factorize a quadratic trinomial. First of all, we look at the last term. Okay, the last term, also called the constant, is, in this case, positive 9. So I'm going to write positive 9 over here. The next thing I want to look at is the coefficient of the x. Now remember, coefficient is the number in front of the term. So the number in front of the x is a plus 10. Positive 10. And what I'm looking for is two numbers that multiply to give that constant and that add to give this coefficient of x. And the best way to think about this is to start thinking about the factors of 9. What numbers multiply to give me 9? Well, 3 and 3 multiply to give me 9. The only other option is 1 and 9. And we're looking at these to go, which of these are going to add to give 10? And it's pretty clear to see that it's actually going to be these ones here. 1 and 9 are going to add to give 10 and multiply to give 9. So what I'm going to do on the next step is I'm going to split up 10x squared and rewrite it as 9x and 1x. And I get those 9 and that 1 from over here. And why I'm going to do that is going to become evident at the next step. I can then just copy these lines down here. And I'm going to put an equal sign to say that this line is equivalent to this line. They're both the same thing. The only difference is I've rewritten the 10 as 9 plus 1. Now, what I'm going to do is I'm now going to treat this as a grouping in pairs problem. So I'm going to think of these two as being together, and I'm going to think of these two as being together, and I'm going to look for a highest common factor of them. Well, looking at these ones, the highest common factor is going to be x. And for these second two, there's actually not really a highest common factor. The highest common factor is going to be 1. Okay, I want something to come out of that. All right, and the only option I have is 1. 1x divided by 1 is 1x or x. 9 divided by 1 is just going to still be 9. And we can see here that we do get that nice repeated term in the brackets. So just like grouping in pairs, I can pull that out the front and I end up with this in my factorized form. Now I want to make a couple of points about this. It's very nice that this x plus 9 occurred here. And that happened because of the way that we selected these numbers here, because of this stuff over this side. If we choose the wrong numbers here, we won't get this happen, and we won't be able to factorize it. Just like I said that grouping in pairs problems tended to be rigged so that this would happen, basically we're doing the rigging here. We're basically forcing this to happen because of the way that we choose these numbers. Now something you'll notice is that these last two brackets actually have the exact numbers that we found here. Okay, we've identified it as 1 and 9, and we saw that the result here, that 9's not very clear. Okay, the result here had an x plus 9 and an x plus 1. And at high school, you probably got so familiar with these that you could go, as soon as you identified this, you would go straight from this first step down to that step, and that would be fine. Now, that's okay, provided that you've got what we call a monic trinomial, and that means that the leading number, the coefficient of this x squared, is a 1. If it's something other than 1, we're going to have to go through a different process, and these middle steps are going to have to be necessary. But for the moment, if it is a monic, and you're sure that it is, okay, then I'm happy for you to jump these steps down to here. Okay, you can do that in one. Again, if you're not sure though, feel free to put these in, and pretty quickly you'll work out what's going on, and you'll want to leave them out anyway. So that's how we factorize a quadratic trinomial. In the next video, I'm going to look at a slightly more difficult example.